using the crowd to prevent harmful AI behavior. So AI systems are becoming more and more ubiquitous, and there are many different types of harm that can be caused by these systems, which we'd like to figure out how to prevent. One of these types of harms is harm that's caused directly by the actions taken by the AI system. For instance, crashing into a pedestrian, recommending an extremely violent movie to a young kid, and so on. We never want an AI to perform these kinds of harmful actions. So we need to involve people to specify constraints that prevent this harmful behaviors from occurring. The question is, who decides what is harmful? And currently those decisions about what is harmful are made by a very small group of AI experts and executives at a small group of powerful companies. And this is a very limited perspective that may itself be harmful. How can we open this conversation up and include the voices of a broader and more diverse group of individuals? So there has been some previous work in this space called Moral Machine, which brought millions of people into the decision-making process surrounding AI harm. The limitation of this was that it was very simplified in artificial scenarios. For example, crashing into pedestrians versus crashing into a barricade. And these simplifications were created by these same AI companies and processed by the same AI experts. So it, in essence, tokenizes the role of society. They're only involved in this one very narrow slice of the AI safety problem, and the rest is handled as always. So we want to ask, how can we empower somebody who is not necessarily an expert in AI to develop effective constraints for real-world scenarios? Now, real-world scenarios are very difficult because they involve things like long-term decision-making and uncertainty and so on, which might be difficult for a non-AI expert to understand. So to begin investigating this question, we developed a video game called Careful Car. Careful Car, the goal is to illuminate issues surrounding long-term harm and uncertainty. So players are playing this car, and to decide whether it's safe to go in a direction, they might need to consider a long sequence of decisions after that. So after playing a few levels, they were asked whether certain actions were safe for the car, but they were never given any explicit instructions about the meaning of the word safe. And despite that lack of instructions, a plurality of them answered all questions consistently with a long-term notion of harm. And the majority of users incorporated uncertainty correctly into their decision-making. So the takeaway from this study is that there's a huge promise for non-AI experts to reason about harm in AI problems, even those that involve difficult issues such as uncertainty and long-term harm. So next we wanted to investigate a real-world domain. So for that we chose riddle books. In riddle books, it's been played by over 350,000 people, mostly young kids trying to understand math. When they get stuck on a problem, they press this help button and the little character pops up and shows them a hint. We want to use the AI to help generate and improve hints, but we don't want it to just free reign over giving any hint in any scenario, because you might show a student something that's mathematically wrong. And that mathematically wrong fact might harm this young kid who's just trying to understand math for the first time. So we created a simple interface where people just said yes or no to indicate whether a hint was reasonable shown in a scenario, and that really didn't do so well, only 27% precision. So we developed this fake gold approach, which ensured that users were carefully considering both parts of the task and how they relate to one another, and that raised performance to 61% precision. Then we added another variation which required explanations only of the yes answers, and that raised performance even further, up to 87% precision. However, users were not being very efficient because they have to decide on each situation in a case-by-case manner. And so we developed this new interface which allows non-AI experts to write rules that can apply to many different situations at once, and thereby make them much more efficient. And we saw that in our experiments, users were able to label an order of magnitude more situations while doing even slightly better in terms of precision using this interface. So in conclusion, we present the first study of how to enable non-AI experts to effectively determine the safety of real-world AI decisions. There are lots of other application domains for this, such as Facebook advertising. The one limitation is we're focused on cases that are fairly clear-cut, albeit complex. More work's needed on cases that are highly controversial as well as complex. Thank you.